questions about the day, where the bathrooms are, the cafeteria, or where other sessions are, I can help you. Just come and ask me. I would like to introduce Chris Pinto and Christian from Team 5406, who will be talking about designing a tablet scouting system.
All right. So my name's Chris. I'm one of the lead mentors on 5406.
I'm Christian. I'm a grade 12 student, and I'm also a programming student on 5406 as well.
All right. So today we're going to take a little bit of time to chat about a scouting architecture. We're not talking really about scouting itself so much. We're talking a little bit about that, but we wanted to talk about how to design a system where we have all of the little pieces of data moving from one place to another. How you go from having data on a tablet to having data that's accessible to someone over the internet in a pit or somewhere else in the world. So we're going to chat about these items. We had originally planned this for about 30 minutes, but we've got a little extra time, so we might extend things a bit.
So why make data-driven decisions? First off, it's important to scout for match strategy. It's hard to make an argument to your alliance partners on why you should do this and why you should run your auto if you don't have data to back it up. So if someone says they can do a 3-ball auto, but data says, oh, they're only scoring 1 out of the 3, it's not viable for them to do that auto unless you can prove to them that, yes, we fixed these changes, or the data shows that it works.
We do find that there's a lot of value in having our scouting be something that's useful throughout the entirety of an event, as opposed to something that's only useful for that one instance at the end. If you can make your scouting data real-time enough that you can actually continuously use it and use it to improve your own standings in the event, that's a really valuable place to be. And having that data allows you to make strategic decisions, make a compelling argument, and that's something that we are trying to push for.
It's also important to learn about the robots at your competition. It's nice to know, like, oh, there's this team that has a swerve drive, or this team can climb the traversal within like 5 seconds. Knowing this info allows you to help plan strategy and as well for your pick list as well overall, which helps you pick your teams. Even if you're not in a picking position, you can help your alliance partners or your alliance captain as well try to pick the team for the job.
We find that a lot of times it's really difficult to make those last couple of picks. It's easy enough to say who the best robot is, maybe that would work well with you, maybe the top 5 robots are. But when you try to choose who the 23rd best or 24th best robot to partner with you would be, that's a really difficult decision. A lot of times, at something like an off-season event, you have a very limited amount of time. You might have 15 minutes, half an hour to turn around from quals to playoffs, and you have to come up with a pick list. If you have data to make an initial first-order sort, you can do this much more efficiently, and then from there you can delve into the details if you've got the time. So having that data available allows us to kind of weed out the little intricacies between the robots that we might be considering and maybe focus in on specific factors that are of interest to us.
So this is an example of our scouting system. It's very organized and allows us to see quickly, okay, what robot, what's going on, what are these robots, what are the stats of these robots, as well as we can use the data to see how we would stack up against other alliances. So this is data from IRI actually, and it shows that if we were to play with these theoretical alliances, who would be scoring the most, scoring the percentage of points, and who would end up winning the overall match.
Yeah, so we collect a lot of data, and having access to all the data allows you to do a lot of different things. First of all, it's just easy enough to look at a particular number. Sometimes we just want to know, how does this team perform? How many balls did they score on average? Sometimes we want to know what's that total number of points. This is something, actually one of the first additions to our scouting platform, one of our students wrote this, and it's really just interesting to do a quick little simulation of if these two alliances were to stack up against each other, based on the number of points that they've been getting on average, how would these matches play out? So in this scenario over here, this team would, in a perfect world, get about 130 points. That alliance would get about 152 points. And we can now see which of these teams are the one that's going to be scoring the most. Which of the ones maybe we want to be putting defense on. So having data to drive that decision is really valuable for strategy. Whether it's strategy in quals, if we have this data before a match, or if it's strategy in playoffs.
So in this graph as well, it's very useful. These graphs are very useful to see how other teams compare. And like, I know one of our lead mentors, Brendan here, loves these graphs. It helps us to gather more useful information and just be able to sort that easily as well. I'm sure Mr. Pinto can elaborate a little bit more.
Yeah, so with all of the possible data points that we've got, we can render them as a graph. And these box plots are really nice. They show you not just the median. So right now this is sorted over here by the median. So sometimes you just want to know, on average, how are these teams going to do? Where are they stacking up against each other? But a lot of times you want something else. Sometimes you want to look at the floor. You want to look at their lowest performance. This is really useful if you are a high-seeded alliance. If you're going into playoffs, you're a high-seeded alliance, and you want to secure a win. You want to be assured at the worst that this robot's going to perform, this is what they're going to be able to deliver to your alliance. On the other hand, if you're a lower-seeded alliance, so if you're a number 8 seed, you might want to come in and say, we might not be able to outdo that number 1 seed. We need to have a little bit of luck, and we want to take the best of what these robots have to offer. That gives us an opportunity to sort by the ceiling and see, if we get lucky, if we get one of these little outliers, maybe this robot can really deliver that come from behind victory that we might want. Looking at this graph, sometimes you want to see, if we have different pieces of our game, if they stack together, how would those totals look? So we can take multiple different facets of the data we collect and analyze them in aggregate here. So for instance here, we've taken the amount of times they've shot in auto and the amount of times they shot in teleop, and we just stacked them on top of each other, giving us a quick breakdown of the total points or the total balls that they scored into that high goal.
So this is one of the cooler features we did implement this year. Since we were collecting data on where teams shot on the field, we were able to actually accurately show whereabouts our teams most likely to shoot. So this is data about us, and during teleop, the blue dots show that we are shooting closer to our hangar area or just far away from the tarmac, which is very helpful, especially in playoffs, where you can show your alliance partners, hey, this team is going to shoot around this area most likely. Go play defense in that area. See if you can mess up their shooting accuracy. It was a really cool feature actually showing our alliance partners, like, oh my gosh, can you show us where we're shooting from? That was one of the first reaction when we were showing our alliance partners this data.
Yeah, what Christian didn't mention is that he's the one who wrote this. So what's really interesting about this is you wouldn't be able to collect this if you weren't doing this on a tablet. Every single shot that our scouts input, it might not be perfect accuracy of where it is on the field, but it gives you a pretty good approximation. This is something that we wouldn't have done in a previous year. It just seemed like it was useful data this year. And knowing this in general gives us a little bit of insight maybe into where they're shooting, where they're, if they're going, especially at this early parts of the season, teams were really repetitive. A lot of teams were only shooting from specific locations. That was useful for us to know in terms of defense, but it was also useful for us to know in terms of how we might want to split up a field if we were partnered with someone. So it helps on both sides. It helps us to know if we're against that alliance, what can we do with that data, and if we're on the same alliance as someone, how would we coordinate our actions?
So the first big question is, why would we even do talent scouting? As I've shown, it improves data quality. It's easy to use as well, and it improves scouter engagement. It's very boring if you're there stuck scouting 120 matches. It can get very dull and repetitive and can make your scouts not really want to do it. Having it on a tile system makes it more engaging for the scouts, and it allows them to be able to be more interactive with the data and have more fun with it overall.
Yeah, we often have a parent scout. We might have another team scout with us. We need it to be designed in such a way that is a small learning curve. Most of the time, someone can pick up our tablet scouting and be scouting for us in about 5 minutes. So it's a really quick learning curve, and it's somewhat engaging. You do have to put a lot of focus in. You are staring at a robot, trying to count everything. That's part of the nature of this quantitative scouting. But at the end of the day, it's a little bit more engaging than looking at a piece of paper. It's something where you don't have to continuously look down. Once you get used to the kind of the motions of it all, you can keep your eyes in the field, you can follow a robot, and all of these things help us to improve the data we're taking in. If you have bad data coming in, you're going to have bad decisions coming out. So we need to have the best quality of data that we can possibly get.
As Mr. Pinto was talking about earlier, the real-time data access is very important. I know in 2019 when we were doing our Einstein run, having that data on all the other teams playing on Einstein was very helpful for us, and we were able to make decisions on how we should play our playoff matches as well. And there's the depth of data as well. It's very useful to know, okay, this team is climbing, takes X amount of seconds. They said they can climb in 5 seconds to traversal, but it's really taking them 20 seconds to climb the traversal. It's very helpful to know that data and how you can play your strategy around that.
For sure. So we take the time to write a new scouting app every year, pretty much. It has some basis in the old one, but we adapt it to the current year's game. This allows us to acquire data that is specific to that game. So this year, for instance, we were gathering timing data on the climbs. We didn't use this all the time, but it was there when we wanted it, and it was something that you wouldn't be able to get from another kind of a platform. If you did like a Google form, for instance, you could record that they successfully climbed. For us, we recorded when they started their climb and when they ended their climb. And that allowed us to say later on, if there were 2 or 3 teams in the same alliance, and we wanted to go back and say, which of these climbs should we defend? All 3 of these robots maybe could do a traversal climb. They were all successful at it. We wanted to know which one was going to take the longest, which one would be the most susceptible to defense. We could accomplish that by looking at that data that we gathered. So we gather enough data that we could almost replay back a match. We know when every action takes place. There's a timestamp for it. We know what that action is, and in the case of this particular game, we know where it took place on the field. Now, we don't render it out as such, but we have that data available to us if we needed to go and do a particular analysis for a particular scenario.
And the last point there is it's being self-contained. Some systems require the students to have their own data plan or to use their own phone, and it's not very accessible to everyone at that moment. If it's self-contained, like if you don't require a data plan or you don't require having a cell phone or you can't do this at a competition, it's very easy to have it in our own system, and they can rely off us instead of having them rely on their own devices and their own resources.
Yeah, this makes it really easy for us to partner with someone. If we need to be able to say, we need a couple extra scouts, you can just hand over a couple of tablets. It's already set up. It's already working. No one has to install an app. They don't need roaming plans in the US or anything. Especially for a Canadian team, when you go to the US, trying to get data plans to work is definitely a challenge. It was not a fun experience trying to figure that out on the bus down to Worlds. So we're happy when one data plan can work and then everything else can kind of go off of that.
So here's a quick system overview of our system. So we have around 6 tablets being used during a competition. They're running Lineage OS, which is a custom ROM of Android, and has the app which was written in HTML and ported over using Cordova. We have a scouting laptop, which is like the in-memory device that's running Node.js and MongoDB, which then you can review the data and send over to the AWS server running Nginx, Node.js, and MongoDB, which allows us to view on the web and make the real-time data.
Right. So from here, we're going to get a little technical. This is the nature of this particular presentation. We are talking about an architecture, and we want to talk about how do all these different pieces interact. So specifically, how do we go from tablet to internet? What are all the little intricacies needed to make this work? So the intent over here is that if someone else was trying to build their own scouting system, what would they need to take into consideration to get these pieces working together?
So the tablets we do use are called Amazon Fire HD8s. They're the 8th generation. There are 3 main reasons why we got it. They're very cheap. They're about less than $100 when on sale. Since we got a lot of them, it's very nice when they're cheap, and it just works. Very little things to change. Recently we had to flash in the custom firmware, but other than that, they just work on the tablet.
Yeah, so the very first iteration of our scouting app, we just built a scouting app, put it onto the Amazon Fire tablets, and it worked. The limitation for us there was that it only worked over USB for data transfer. A lot of teams have explored some other possibilities. Teams do QR codes for data transfer. We did the USB data transfer. But what we really wanted at the end of the day was some other way that we could do this all wirelessly and still play within the rules of FIRST. So that did require a little bit of a change. For us, we have 15 of these tablets. We use 12 of them for scouting at the moment, and that allows us to scout 2 fields simultaneously. So if you find something at DCMP, for instance, you have 2 fields, and at the end of the day, when those fields come together, you might need data on all of those robots. So this year, we had a scouting alliance where we had another team join us. They scouted 1 field, we scouted 1 field, and then all that data together was shared between those teams. if it wasn't cost effective, it would be very difficult to buy a large number of these. We also use these tablets for match review, so we'll use them to film match and then quickly show it to our drive team so that they can look through it, see if there are any things. Memories are quickly forgotten, but a video is there to just kind of go through, recap the match as needed.
So here's the quick tablet setup is they're flashed with a modified bootloader and firmware, and it's required to install Lineage OS. For us, the way we transfer our files wirelessly is through Bluetooth internet connection sharing. And so for us to be able to do that, FireOS, the basic operating system on the Fire tablet doesn't allow that, so we did need to install a custom firmware for that.
Yeah, I mean, we've tried a few different options, and Bluetooth was one that really kind of plays within all of the rules. First, doesn't let you make Wi-Fi networks. You can't hotspot. So the only kind of method that's wireless and local is Bluetooth. You could try to do something over Ethernet, you could try to do something over USB. All of these are viable, but then it really tethers the scouts to the scouting laptop or that scouting station. Having that freedom was really necessary, but we have to have a custom ROM in order to have Bluetooth on these tablets, Bluetooth internet connection sharing specifically.
So for that to be possible, we did have to take advantage of a hardware route, which was essentially taking it apart or taking off the back cover and shorting 2 pins, I'm pretty sure, on the CPU to be able to flash it into the bootloader. It was the most reliable option. There was no soft mod available, so the hardware mod was probably the most reliable option for us.
Yeah, so you can kind of see a little quick photo over here on the side. Basically, we opened up the case. It's pretty easy to open. You short the 2 pins, and as you short the 2 pins, you boot up the tablet. This basically puts the tablet into a mode where it'll accept new firmware onto the bootloader. It's easy enough to root these tablets. That'll give you a lot of the capabilities that you need, but it's not enough to install a new operating system on there. If you want the new operating system, which we needed for the Bluetooth internet connection sharing, you do need to actually open this up, do the shorting of a couple of pins, and then proceed from there.
And of course, you need to install a custom bootloader, which is TWRP. That's our choice. It's custom recovery, and we installed our version of Android was Lineage OS version 14.1. It was Android 7. It was just the option that's available at the time. It just does the job. We've seen no reason for us to update towards a newer version of Android, and it just works.
Yeah. So when we first did this, took a couple of tries. We tried a few different versions. We first did this in 2019. This was our kind of our first foray into the Bluetooth version of this. We got a chance to try this out at Ruckus. Wrote part of this on the bus down there, I think. But from that point, we had a working test bed. We knew that this tablet would do the Bluetooth connection sharing. It would work on this version of the operating system. And while there are newer versions, there wasn't any advantage. There's no compelling features that would make our scouting better. So sticking with something that's known is perfectly good. You don't need to have the cutting edge version of Android installed and incur a new learning curve every time if the one that's working is already there. So we've stuck with that even though it's a slightly older version of Android.
Of course, the custom app that we do make is compiled on a computer, and it's all transferred over USB to the devices.
And at the bottom, we've got just a link over there. That's the procedure that we followed for actually setting up the custom ROM onto the devices, for fixing up the bootloader, getting on TWRP. It's fairly nicely documented on the XDA developer site.
So for us to transfer the data from the tablets towards the computer, we do have to have a scouting laptop. So it runs the Windows 11. There were recent issues with Windows 10 that the Bluetooth internet connection wasn't as well working. It was a little bit buggy, so we ended up switching towards Windows 11. And it works better. It just does the job.
Yeah, they originally, in 2019, we used Windows 10. It was working at the time. Pandemic came. We went back this year to try and use this again. Windows 10 would not work at all. We could not make the internet connection sharing over Bluetooth work in Windows 10. We decided it was time to upgrade to Windows 11. Everything seems to work fine. We ran it for the season without any issues from there. What's really nice is you can connect 7 devices. That's just the perfect number. It allows you to have 6 devices for scouting, and have 1/7 as a backup, so if something goes wrong, you can just hot swap in that 7th device and be ready to go with no loss of data.
And so, of course, the tablets are paired to the laptop over Bluetooth, and they do have network connection sharing enabled, which allows it to get an IP address and be able to connect to the internet and talk to our tablet and send the data over.
And this is the fundamental feature that we really wanted. We wanted to not have to write something that handled custom Bluetooth data. We didn't want to be able to be transmitting things over serial or anything that had to be a fully custom solution. We wanted to be almost as off the shelf as possible, and it really doesn't sound very off the shelf, I have to say. But at least in terms of the software we're writing, in order to be nice and extensible, to be able to work from year to year, we wanted that to work on standard settings. So at the end of the day, the app on this tablet's just transmitting data over a network, just as if it was connecting it over the internet or between two servers. It doesn't even know that it's transferring it over Bluetooth. So to the app and to the tablet, the Bluetooth part of it is completely transparent. It's just another IP address, and it's just transmitting it over a network.
So the app architecture is we use HTML, CSS, and JavaScript, and it's compiled using Cordova. We purely choose this type of setup is because the students on our team do learn sometimes, depending on the courses they take, JavaScript in class. So it's very easy for them to have the opportunity of having some background knowledge in this language, and instead of knowing 15 different languages, it's better to be standardized on one type of language.
Yeah, Apache Cordova is a really cool platform. It used to be called PhoneGap, and what it is it's a cross-compiler. It lets you build a native app, as in this case an Android app, using web technologies. And this is something you see more and more these days. If you kind of looked at some SpaceX things, their Dragon capsule interface is built in web technologies. It's something that you would never have imagined a few years ago, that you would use HTML or JavaScript to be providing the interface for a spacecraft. And if they can do it, we can do it as well. So we have kind of standardized on when you can use web technologies, try to use some web technologies. What's really nice over here is each page, each screen of our app is just contained within a div. That's the way that Cordova sets this up. And then you just use your web technologies to populate that div. From there, it's just all JavaScript for all of the interactions.
So when the match is done and you need to just send the data over to the scouting laptop, it's posted to the server running using a JSON file. It's also saved locally, so just in case the scouting server, for whatever reason, is not working just for that second, or something goes wrong and you still need to scout and you have a 5-minute turnaround and couldn't get the server back on, you still have a file saved locally, and so later on you can upload it manually over to the server.
As much as we like to have the Bluetooth system, there are always little things that might go wrong. And having some amount of redundancy, having a backup, even if accidentally you deleted the data, it got transmitted to the scouting laptop, we delete it somehow, we've got a copy of every single match saved. If we do a scouting alliance, there's a copy of all of the scouted data that ends up on the tablet that we can always recover later if something doesn't work out, which is really nice. Just having a backup takes a lot of stress off the people who might be running the scouting, knowing that you haven't missed the match data. It's there. It might just take a little extra work. It might not be as real time, but it is available.
So here's an example of our 2019 scouting app. As you can see, we have large buttons. Having large buttons available allows you to very easily click what's going on, and you don't have to be focused on the screen. You can just look up and say, okay, they score a hatch on that level 3 of the rocket, and they score also cargo down. It's very easy to be able to just know that this button's here, and I can know what's going on.
Yeah, it's designed to be easy to use. So a quick picture, a different color, things that you don't have to read words for, and big buttons where you don't have to focus on the intricate touches. We, in this particular version, we had a list of all the actions, so you could swipe away if you wanted to undo something, and just a differentiator between if you're in teleop and auto. That's something that we will come back to a little bit later as a thing to work on. This is something we find that occasionally, often, we end up in our scouts stay in auto and scout more of the match in auto than they should, but future revision.
So for our next one, this is our 2022 scouting app, and this is how it looks in auto. We have, once again, large binds for like if a foul takes place, or if the robot taxis, or if that human player managed to get that lucky shot in. As well as a large field, so you can accurately say what this team is shooting from this area on the field, and it allows us to get those data points as well, which are helpful for the field shot, as we showed earlier.
Yeah, and we look at this a little bit more in the next slide, so it's a very similar next slide, so we'll just flip over to the next slide then. And the basic gist of this is we decided to go with this target kind of structure. You would put your finger wherever the shot happened, and you would basically flick up, down, left, or right. And you'd make the choice from there. So high would be that they shot from this center coordinate over here, and they got it successfully into the high goal. Or you go down if they got it into the low goal. If they took the shot and missed, that's useful information to us. We might want to know their cycle time. So sometimes, if you on a lot of platforms, you might only count they actually scored 10 cargo. Here, we count that they missed 5 maybe. That tells us how long they're taking to pick up a ball, how long they're taking to cycle, and that's really valuable information. We ended up not really using the error side so much, but at the start of the season, there was the possibility that teams would be picking up the wrong color ball and shooting it by accident. It proved to not be something that was really common during the match. We do also record some climbs, and maybe you can tell us a little about those.
It's very useful to know when teams are climbing and how long it takes for them. So if you just click the start climb button, it's from the start of when they line up at the hangar to when they get to their desired goal. And it's very useful to know, did this robot fall? Did they actually make the climb they promised? Did they make that 7-second climb? Did it actually happen? And this allows us in a very easy and simple way to be able to figure that out.
So we just hit start climb, and then whatever happened. If they fall, we can do it again. We can say that they tried 3 times. And that's perfectly okay. And then in our data aggregation, we just take the highest result of that for looking at the actual points. But we have the data available to say that they have to try 3 times in order to get that actual mid-bar climb.
And of course, towards the end, it's very useful to have, as much as quantitative scouting is useful, qualitative is also just as important. So it's very nice to be able to say in a comment section, they were heavily defended. 118, they had that defense on them the entire match. They said they can score 20, but they only scored 10. Maybe that's the reason why they didn't score as much. Also important to know, did that robot die on the field? Was not able to move anymore? Did something happen? And is anything of that robot broken? And a little side part is you can make it more engaging for our scouts. You can attempt to draw the robot that you were scouting, or just draw something in general just to make it more engaging. And it's fun to look over after the competition's over and be like, oh, that's a really funny drawing. Nice one.
Honestly, the drawing, as silly as it might seem, is as part of the driving factor of this being Bluetooth. You could accumulate a lot of this data in a QR code, but a QR code has its limitations in terms of the size and the amount of data that you can transmit. If you decide to start putting drawings into things, the size of those data packets goes up a lot, and you just can't fit into a QR code anymore. And these were so valuable to us that we decided it had to be Bluetooth. We had to put in all the extra effort just for the drawings. One of the nice things, though, is this gives us a quick first-order sort for something like defense. It's really hard to describe if defense is good or bad. A lot of times we want to know some amount of quantitative data that can say, were they playing good defense? Were there some instances where they played good defense? At very least, it gives us a chance to go back and say, I want to go and watch that one match. If all that we have is a comment that says they played good defense, and you have to try and sort through a whole bunch of comments and read through that, it becomes really difficult when you've got a short amount of time. When you've got at least something that says, this robot played amazing defense in 3 matches. Now that's a quick first-order sort to just say, hey, we can go through, we can look through that and pick out all the best defense robots really quickly if that's something that we're looking for. We usually do follow up with the robots dying or breaking, and that gives us an opportunity to go and try and investigate why did that happen. Is that an ongoing problem? Is it something that just happened once? And maybe that informs a decision later on for a pick. If this is a robot that's continually dying on the field and they're not very reliable, that might change the opinion of the rest of the data. Even if they're scoring a lot, if we can't rely that they're actually going to be running, that might have an impact on it.
So the scouting laptop, it is running a Node.js server, and it runs Ultim MongoDB document database. It receives data from the tablets, of course, over Bluetooth, and it's stored locally on the server as well, on the laptop as well, which helps improve redundancy as well. So just in case something didn't get actually uploaded to the server, it's very nice to have a redundant way of saying, yes, the data is actually on the laptop and on the tablets as well, just in case something didn't go right.
Yeah, this also allows us to not have to always bring all the tablets with us. If for some reason we can't get a network connection, we can't upload to the internet, we just have to take the laptop to any place that has a network connection, whether it's just walk outside the building, get ourselves a hotspot outside, and we can upload all the data from there. One of the motivating reasons for Node.js and MongoDB here is, again, standardizing on a language. Using JavaScript on both the app and on the server side allows us to use one language everywhere. Otherwise, you have to choose multiple languages. It's a larger learning curve. It's just a problem. MongoDB is designed to work well with JavaScript object notation, JSON files. And this is exactly what our scouting tablets are generating. So it's a continuous set of the same language from one end to the other, where we don't have to do any conversion, we don't have to change between file formats. It just allows for a nice seamless transition.
And so when the data is received from the tablets to the laptop, it's very easy for our lead scout or whoever is running the scouting to look over that data very quickly and say, wait, why is there 20 balls in auto? That doesn't seem right. And you're able to quickly change that and make sure that that data actually is correct and does actually seem reasonable instead of it having to be done over later on throughout the day.
Yeah, a lot of times we want to come back and just see, have we gotten all the match data from the 6 scouts that were scouting right there and then? What happens for us here is that as those scouts finish scouting the match, they finish the little survey at the end, they hit submit. That data gets transmitted automatically and updates a local page via WebSockets. So it gets received by the server that's running, that Node.js server. WebSockets will update to show us that we've got a new data entry, and then we can go through that, we can look through that data entry, see if there are any problems, and if needed, make any changes.
And of course, once it's done, it's uploaded via that tethered hotspot to the internet. So for the cellular upload, as much as we all know, the FTAs aren't too pleased when you create your own network at an event, so it has to be over USB. So we take advantage of a Rocket Stick, which, but it's very easy to use like a cell phone or anything else that has a cell connection, which is a very, it allows us to have many options and we're not always reliant on one option.
Yeah, this is letting us just have one single data plan or an item that might be owned by a team, and we don't need individuals to have their own data plans, especially when we're roaming in the US. There are a lot of other versions of scouting where everyone scouts on their own phone. It's great if you have internet access, but this allows for one place, one single point of uploading, and it has worked quite well for us.
So when we do share the internet that is being shared to tablets, it is the internet from the cellular, from the Rocket Stick, the cell connection. Overall, the total data usage is about less than 10 megabytes for the event, unless you have installed Windows Update, which we learned the hard way. So that's why you need to make sure you set your connection to meter overall.
Yeah, so each individual match or robot that gets scouted is between about 4 kilobytes and 12 kilobytes. Depends on how detailed the drawing is, really. But over the course of an entire event, we're still looking at a relatively small quantity of data, even with all the lovely drawings that we gather. And it's quite easy to transmit this. It doesn't matter the speed, even at a very low speed connection. You can still get this data up and live in pretty much real time.
So for the architecture for our backend, as I said before, it's running on an AWS server with Nginx, Node.js, and MongoDB, which I'm sure Mr. Pinto can elaborate a little bit more on. AWS is Amazon Web Services. It's a really well-known cloud platform. We use a cloud server over there, and there are a couple of little pieces to that architecture. There's a server that's exposed to the internet. So Nginx is a very high-performance server. It's designed to serve a lot of pages very quickly. This basically protects the slower-running Node.js from a large influx of traffic. It's very efficient at serving things like pictures, so if we want to do a gallery of robot photos, for instance. Node.js is very slow at that, but Nginx is really quick at serving static files. Nginx takes the incoming request, and it handles all the decryption over SSL, and then proxies that request to Node.js that runs in the background.
This is the exact same Node.js kind of instance that we're running on our Scouting laptop. So again, trying to just standardize components so we don't have to learn new technologies all the time. The Node.js instance here is running different software. It is running the public-facing part of the Scouting architecture. So this is what someone in our pit might go and access in order to view the graphs, in order to actually view the data. This is also what listens and receives the connection from our Scouting laptop. And of course, standardizing once again, we use MongoDB in the background to store all of this data. So pretty much just goes from our Scouting laptop to the server, gets stored in a very similar format on the server.
And for the front end at least, it's very easy to make a web page. It's very hard to sometimes to make a web page look nice. So it's nice to standardize on certain libraries. So that's why we use Bootstrap. It's just a very nice library that's available that allows you to make web pages very pretty and provides everything for you. It does the work for you. This is very nice when you have those tools available and there's no point of rewriting something that already exists. It's there, use it. We use jQuery as well. It helps make writing JavaScript 10 times better. If you're not using jQuery, use jQuery. And Plotly, we use another library we use. It helps us make those graphs that our mentors really like. And it just makes everything a lot easier to do. Once again, if it already exists, there's no point of rewriting it.
Absolutely. As much as it might seem like there's a lot of custom stuff that goes on behind here, if we don't have to write something, we don't want to do that. We want to just be able to use something standard, and especially if we're throwing it together at the last minute, the fastest version that'll get us to where we need is what we want.
So for the future, the Scouting app is far from perfect. We still have a lot of plans that need to make this app better. So currently, every year it needs to be rewritten, which sometimes it can be less than ideal, but it also helps us in the end. So it's a double-edged sword. It's sometimes good, sometimes bad. We hope to make it a little bit more accessible and a lot easier to write instead of making it last minute.
Yeah, it honestly has been something that our Scouting app is not necessarily the perfect version of a Scouting app, but there is definitely some interesting technologies at play that come together to make it work well. Rewriting it every year, it's something that allows us to make some improvements. We've got a bit of a longer-term roadmap of some of the features we want to add, and every year we add in one or two of those. But invariably, it's something that's happening on a bus or in the stands just to get those last couple of features working out at the end of the day.
It's my first competition. Another feature we hope to implement better was Scouting alliances. So especially at DCMP where you have two fields, it's very useful to have work with another team to work on a Scouting alliance. So improving more features towards that, making it more accessible for different teams would be more than ideal.
Yeah, at the end of the day, the data is kind of the same. It's not having that data necessarily that drives everything. It's what you do with that data. And that's the kind of secret sauce that the teams really covet. But the data itself, replicating all of the work to gather that data is just a lot of redundant labor. So having teams that can collaborate, lend a couple of students together, form an alliance where a number of teams have all partnered together and they can all share the data and they can then allocate those student resources to something else is really a good outcome.
And of course, since we do have an internet connection, we can take advantages of things like the Blue Alliance's API, which could allow us to automatically get the match schedule. And so currently, for us to get the match data, we need to, right before the event starts, recompile a new version of the app and get the match times and for the current alliance and set that all up. It'd be very nice if we can just use the Blue Alliance or use a different API, even if the FRC events API, and just get all that data a lot easier and not have us making it last minute.
Yeah, with Bluetooth, it is in fact a two-way street. It's not just from the tablet to the Scouting laptop. We have the ability to go from the Scouting laptop to the tablets. So we can transmit information from that Scouting laptop, whether it's a configuration, whether it's a change in the match schedule, whether we're trying to set up playoffs, something we don't know in advance. All of that can be transmitted from that Scouting laptop back to the tablets in order to configure them on the fly. Another thing in the same vein over here is just redundancy of data. We right now scout one robot per person per match. Unfortunately, sometimes you might not have the best data quality coming out of that. Something gets missed, the tablet doesn't work, whatever the case may be. If we have the bandwidth to do so, scouting 2 or 3 people on the same robot will provide that redundancy where you can be assured then that you can take the best of those that data set and be confident in your data, better decisions.
Another feature as well is like to extend our the app support for qualitative and pit scouting. Currently for us to get pit scouting, we do it over a pretty sure Google Sheet, which is less than ideal, but if you can have your own system that can automatically organize it pretty, you can once again manipulate that data to be more favorable for you, and it makes it a lot easier to understand the data as well if you have the control over it. It's not as easy when you're relying on someone else to do it. If you can have the control over the data, it just makes it a lot easier.
Yeah, we're hoping over time to integrate a lot of the different facets of scouting into one singular platform. And I know that a lot of other systems do this. We do like some of the customization in our app, some of the flexibility that it offers, but we found that sometimes, as some of our scouts will tell us, that it's more than just the numbers, that sometimes the numbers do lie. That you need that qualitative insight where you can look at some of the characteristics that teams are demonstrating on the field that might be really hard to capture in numbers. And being able to integrate this into the same page where we have information about a particular team would be very valuable. And even the pit scouting, right now we do take photos of robots. We try to add them into the same page, so when you're talking about a robot, you at least know what robot is this. As much as FRC loves its team numbers, sometimes when it's late at night and you've been staring at a bunch of numbers, you really don't remember what does this team look like? What kind of mechanisms do they have? Can they actually do this thing that we seem to say that they can do?
And finally, just improve data review. As we said, we do have the option for whoever's running the scanning system on the laptop can review the data, but it's very technical. It's literally just the JSON object on the page, and it's requires pretty much some basic programming knowledge to understand how it works. It'd be very nice if we can have it so it's not as technical and anyone can do it. Anyone can review the data. It's not just reliant on a program.
So we did a lot of data review this year. We had an opportunity to go back, clean up some of our data, made a big difference to getting a good quality of data, but it definitely requires technical expertise beyond what we might be able to spare at a competition. Requiring someone who has basically written the app at some point to be sitting there scouting is a significant burden that we might want to remove and make it so that it's an easier job and the people with that set of expertise can be focusing on a robot or some other software problems that might be coming up. All right, so that's what we're chatting about. As I said, we kind of aimed this for a half an hour, and I think we kind of kept to that timeline. But we're really happy to answer any questions that people might have. It was a little technical at times, but hopefully it gives you a good starting point for where you might be developing an app and where you might want to see these various pieces interconnect. So any questions that people might have? Yes.
Have you seen any scouting systems from other teams that have features that you like or don't like or want to steal?
Yeah, so there are a couple of other apps. So actually, we were sitting in the stands at IRI. There was a team beside us. They had just a nice web-based interface. Everyone pulled it up on their phone. It was really convenient because you didn't have to have the tablets and everything. But they were a U.S. team, so this kind of worked for them in the U.S. The downside there was that they needed to have their own devices, and everyone looked a little bit different, but the flexibility where someone could be scouting from home on their own device would be really nice. Right now, you need to install the app, and if I was scouting at home, virtual scouting almost became a thing this year. If I was scouting from home and I wanted to be scouting on my laptop and entering some data, I probably wouldn't have a Celtex tablet with me. I probably wouldn't have had all of those things set up, and just a web interface there has some advantages. Because this is written in Cordova, we have the opportunity to build this as a web app as well. It might be something we explore later on. There's also a couple of apps that have been coming up. Sorry?
I mean, we make free apps.
Right. We could do we can compile for Android, for iOS, and for the web. Multi-platform. We'll publish it to the App Store. There is Fire's scouting app is fairly well known. It's got a lot of posts and chief, and I think they integrate their pit scouting into that really nicely. So they've got not only the quantitative scouting, but they've got the pit scouting, they've got the photos, and that's something that we really wanted. So there were a couple of little features from a few other places and from some of our own kind of longer-term roadmap that we would really like to see in there. We really want to be able to do some of our a ticketing system almost, where right now we see that the robot's died or it's broken. It ends up going onto a Basecamp thread. It's the project management system we use. Someone goes and follows up with that and maybe or maybe not posts something about that onto that thread. And later on you have to go back and look at, I'm interested in this robot, they died, why did they die? Go to a Basecamp thread, look at it there, or someone maybe remembers. It would be nice if it's just all in the same place. It'd be nice if it's just, if someone said robot died, that's an automatic flag. There's a list of, go check out all these robots. Someone has to go and check out these robots and write a little follow-up of, okay, they died because their battery came unplugged. We've got a resolution to it. We know why it is. All integrated into one place. Having pictures go up a little bit easier would be a really nice thing, especially pictures of individual mechanisms. I think Fire's scouting app does that, where they have the full, like you do your whole media gallery, and it all gets integrated in one go. So you don't have to have a separate set of photos. You take your photos on the tablet, you take it around, and it all gets integrated really nicely. So that cleanliness of just integrating all these different pieces is something that some of the apps do really well. Some of the other apps also do customization really well. It doesn't give you the same flexibility that a complete rewrite does, unfortunately, but it's a lot quicker. All you need to do is, and we kind of had this in 2019 or prior to 2019, where it was a drag and drop interface. Yeah, you just had the boxes, but you were limited to the boxes. You could put the boxes wherever you want. You could change the image on the boxes. You drag and drop them around. You save the configuration file. You've got your app ready to go. And that was the original plan, that it would be one app for all time. You would just have this configuration page. You drag the boxes around, and you'd never have to rewrite the app. Like minor revisions here and there, but it wouldn't be a rewrite every year. But no, like you find that you learn so much from year to year that there's a lot to change, and you also want to capture some game-specific data, which is really hard when you're limited to just a set of boxes. Now, maybe there is a solution there where you can have enough different widgets that you can capture all of the data, and that probably holds true. Over 4 or 5 years, all the different game types where you capture, I need to capture a position, I need to capture a time, I need to capture an action. If you have little widgets for all of those things, and you can then just drag and drop, I need this widget, and this is the way we build our app, that could be a really nice configurable option over time.
I know 1620 as well. The inspiration for the Blue Alliance integration was actually from 1620. I remember reading their scouting white paper in grade 9, well, that's long ago. And it was very cool to see that they were able to integrate other features from other data sets and be able to just make the life of their scouts easier. Also, some like little things. I know 1690 has their scouting dashboard looks very pretty. There's ways we can make it look just more aesthetically pleasing. I know it's not our top priority, but just being able to make it better, make it easier for people to see is always nice to have.
For sure. Yeah, this doesn't always look pretty, but it usually gets the data that we need at the end of the day.
It does the job.
Any other questions? All right. I think that means we'll give people an opportunity to wander around, take a little bit of a break. If you do have questions, we will be here for most of the rest of the day. And if you do have other questions, feel free to send us an email, celltextrobotics@gmail.com.